Hello, this video is all about solving triangles. To solve a triangle means that we want to solve for all unknown sides and all unknown angles. So for example, in this triangle, there is two angles that are given and one angle that is unknown. And there is one side that is given out of the three, and there are two sides that are unknown. So here there would be two side lengths that we would need to solve for and one unknown angle measurement in order to fully solve this triangle. So first of all, if a triangle is given to you like this with no labels on the vertices of the triangle, you can come up with some of your own labels to put on there. So I'm going to call this triangle ABC, just so that we have some notation to use for our calculations. And sometimes it might be helpful to even make a quick list of which values are known information and which are unknown. So in this case, we've got angle A is unknown. Angle B we know is 90 degrees. Angle C we know is 52 degrees. Side length A is unknown. Side length B is unknown. And side length C we know is 4.1 meters. Okay, then we go about trying to find ways to solve for those unknown values. So if we look for angle A, we notice that we already have the other two angles inside the triangle, and we know that three angles inside any triangle total 180 degrees. So we know that angle A is equal to 180 degrees minus the other two angle measurements, so minus 90 degrees and minus 52 degrees. So we get that angle A is equal to 38 degrees. Okay, so that's one of our unknowns that we've now solved for. So now we look for either side length A or side length B. So let's say we're looking for side length A. Here I can use my reference angle of 52 degrees, or now that I have angle A, I could also use angle A as a reference angle. Either one will work. So let's say I stick with the reference angle of 52 degrees. Then the 4.1 meters would be the opposite side, and side A would be the adjacent. And we can then use the tangent ratio to solve for that unknown. So I've got the tangent of 52 degrees is equal to the opposite, so 4.1, over the adjacent, which is side A. Okay, so side A is in the denominator here. That just means we have one more step in solving. So first we multiply both sides of this equation by A. So we get A times tangent 52 degrees is equal to 4.1. And then to get A by itself, we divide both sides by tangent 52. So A equals 4.1 divided by tangent 52 degrees. And so we get that side A is equal to 3.2 meters. Okay, so we've got this unknown done. And the next unknown is side length B. So that's this side. Now, since we already have two sides of the triangle, we could use the Pythagorean theorem to solve for side length B, or we could use a very similar strategy to how we just solved for side length A, and we can choose an appropriate trigonometric ratio to solve for side length B. And it doesn't really matter which one we choose here, as long as we're choosing one of those appropriate strategies in this case. So here, let's use the Pythagorean theorem, which tells us that the hypotenuse, b squared, is equal to 4.1 squared plus side A was 3.2 squared, which means that side B is the square root of all of this. And if we punch that into our calculator, we get side B is about 5.2 meters. Okay, so now that we have our angle A, our side A, and our side B, we've solved for all of the unknowns that we originally had at the beginning of the problem, which means we have now solved the triangle. Okay, here's another question. And again, we're going to solve the triangle, which means we want to solve for all of the unknown sides and angles in this triangle. And again, this triangle isn't labeled, so just so that we have notation to work with in our question, let's label these vertices as D, E, and F. Okay, so our known values and our unknown values, we've got angle D is unknown. Angle E we know is 65 degrees. Angle F is 47 degrees. Side length D is unknown. Side length E is 15 centimeters. And side length F is unknown. So in order to solve this triangle, we need to determine the values of angle D, side length D, and side length F. So first we notice that we already have two angles inside the triangle. So to solve for angle D, we can simply start with 180 degrees and subtract the other two angles that are there. So angle D would be 180 degrees, subtract 65 degrees, subtract 47 degrees. So angle D is equal to 68 degrees. Okay, that's one of our unknowns that's done. Next, we can look for either side D or side F. And because this is not a right triangle, we're not considering Pythagorean theorem as an option, and we're not considering the primary trigonometric ratios as an option for solving. So either we're looking at sine law or cosine law. So if we're looking for side length D, we can set up the cosine law because we now have angle D is 68 degrees. And we have a full ratio for angle E and side E. So we have that matching angle and side pair. So now that we have angle D, we can solve for side length D using the sine law. So we have that D over sine D, which is 68 degrees, is equal to side E, which is 15, over sine E, which is 65 degrees. Okay, multiplying both sides by sine of 68 degrees gives us D equals 15 times sine 68 divided by sine of 65. And putting that into our calculator, we get that side D is about 15.3 centimeters. Okay, finally, we're solving for side length F. And again, we can set up the sine law here. So we have side F divided by sine 47 degrees, which is the opposite angle to side F, is equal to, let's use the matching pair for angle E and side E again. We've got 15 over sine 65. Multiply both sides by sine 47. So we get F equals 15 sine 47 divided by sine 65. And so side length F is about 12.1 centimeters. So when we're solving triangles, remember we want to solve for all unknown sides and all unknown angles. And we can do that using any of the methods or strategies that we've learned for solving for unknowns in triangles. So that includes the sum of the angles is 180 degrees, the Pythagorean theorem, the primary trigonometric ratios, so the sine ratio, the cosine ratio, and the tangent ratio, and the sine law and the cosine law. So we use any combination of those strategies as is necessary or as is appropriate in each triangle that we're working with.